Okay, so you need to have out your lab observing physical and chemical changes. And I'm going to trust you guys to pause the video here, read the introduction and the objectives, and then I want you to go through and read all of the safety and procedures before we get started. So pause it here and read through all of that stuff first. Okay, so it says, as you perform the experiment, record your observations in the data table that follows. Step 1 says to obtain a level teaspoon of copper 2 chloride dihydrate in your beaker from the demo bench. Make as many observations of the crystals as you can and record these observations in your data table. So I'm going to come here and I'm going to get a nice scoop of my crystals and I'm going to put it in my beaker. And I'm going to let you guys see what the crystals look like. Try to get you good up close. So go ahead and pause here and write down all your observations of the copper 2 chloride crystals in your data table. Step 2 says carefully add tap water from the sink to the 50 milliliter mark. Do not stir. Observe both the crystals and the water and record your observations of the mixture. So we're going to do that real quick. So I'm going to take this and I'm going to very gently pour that in. And then without stirring it, I'm going to get you as close as I can. So you might right now go ahead and record your observations of the water and crystal mixture in your data table. It also says to insert the temperature probe into the beaker and click collect. I'm not going to click collect, but I am going to kind of tell you what it says. Our initial temperature here right now, which is not the temperature we need in our data table, I'm just telling you right now it's 21.8 degrees Celsius. So then it says to stir the mixture with a glass stirring rod until the crystals are completely dissolved. So I'm going to set this so that you can see while I stir what's happening. Okay, so those have completely dissolved. So I will bring this up closer so you can see. Go ahead and record your observations in your data table. You can pause the video here. Our initial temperature that you're going to want to record in your data table is 21.8 degrees Celsius. Excuse me. The next thing it says to do is keeping the temperature probe in the beaker and loosely crumple the aluminum foil into a loose ball. So I have a nice loose ball of my aluminum foil. Place the ball into the solution and record your observations of the mixture. And I'm going to go ahead and start my temperature collection. Okay. So I've put my aluminum foil in the mixture and I'm going to use my stirring rod to kind of poke it in there. Make sure it gets really good and in there. So you're going to want to watch as this sits in here and see what happens. So don't pause this time. Just keep observing. I'm going to scooch this nice and close so you can really see what's going on. as you can see, the result is kind of this brown chunky stuff at the bottom, this sort of reddish brown chunky stuff at the bottom. And we've ended up with a much less blue liquid. It's much more of a grungy, clearish gray color. And the aluminum foil kind of fell apart a little bit. There's still some of it left, but it's really started to kind of fall apart and break into this brown stuff. Okay, so record all your observations in your data table. Now, I want to talk to you guys really quickly about your analysis, because the purpose of this lab was for us to record all these observations here. But remember, the teak that we are looking at is to be able to differentiate between physical and chemical properties and changes. So what I want you to do with all these observations, these are your physical and chemical properties and changes. All your observations that you took today, those are all either a physical property, a chemical property, a physical change, or a chemical change. So your assignment is to sort those into the correct category, because that's the teak. Can you take your observations and identify them as a physical property, a physical change, a chemical property, or a chemical change? Okay, make sure when you got your observations that you are eliminating any of these that are interpretations rather than observations. Remember, we talked when we did the not a candle demo at the very beginning of the year, we talked about making sure that what you are saying is actually fact. Make sure that what you're saying you know to be true. So like if you said that this was rusting, well, we didn't have any iron in there, so that's not rusting. You can't call it that. Oh, I forgot to tell you, highest temperature we reached was, it looks like 27 degrees Celsius. So 27.0 degrees Celsius was the highest temperature we reached with that. All right, so what you need to turn in, you need to do this question and then all of the post-lab questions as well. If you do not do the analysis part, you have a 0 because you don't get credit for watching the video and just filling in the data table. You need to actually show me that you learned what I needed you to learn. All right, get this turned into me ASAP, please.